Hello and welcome back to Ganesh Institute. So we discussed about what are ordinary differential equations. Now the topic comes as we have to solve a differential equation, or we can say various differential equations, using a technique called as variable separation equation or technique. So here as the name suggests, we have to separate the variables in order to find out the solution. For example, if the question is solve the differential equation and the differential equation is this, how would you do that? So first of all, screen the equation. If you can completely make it one of a kind of explicit or implicit. That means, can you separate this equation on the basis of dy by dx and take every other variable on the different side and see if y can come on one side and x components can come on other side or not. Let's try. So this is dy. If I want to have y component on one side, this is the way, right? I have brought down this y square plus 1 onto the left hand side. Now here x is left. I'm taking this dx onto the right hand side and this x plus 1 as well onto the right hand side, right? That's fine. So we managed to separate. Now y on one side and x on one side. Once you do that, start integrating both sides with respect to the components of integration given here with respect to x, here with respect to y. Okay, so if we do that, so we are literally doing this, right? So this is 1 upon x square plus a square form, right? And that is tan inverse x by a. So the formula will be tan inverse y. Here this is okay. Let's do plus 1 minus 1 here. There are various methods. So let's try this thing. And if I do so, this will become, I'm separating it. So x plus 1 by x plus 1 dx, and here 1 upon x plus 1 dx. So it will give you, this is 1 dx, that is x, minus this is 1 upon x form. So it will be log x plus 1 plus c. This is the answer. So see, there are two types of solution when you solve a particular differential equation: general and particular. It is general because I have kept integrating constant here. So this, whenever you have an arbitrary constant, then that is general solution. And if let's say question would have asked us that find out the value when x is something and y is something, then on putting these values into this solution, you would get the value of c, and after putting it again into this equation you would get particular solution. Okay, let's try another question. So let's say again I need to solve this equation, and question is not telling you that do it using separating the variables. You need to figure out whether it is of that type or not. Okay, so this is the question. All right, what I'm supposed to do? uh, this is the mix of x and y, right? In whatever way I would try, I would not be able to separate it fully in terms of dx and dy, right? Okay, let's try what we can do. Can we rearrange it as if, okay, Let me keep this one on the left hand side only, and I'm taking this minus component onto the right hand side by making it positive. So this gives me 3x square 2y square minus 8y dy, right? Now I'm clubbing the differential coefficient all together. So let me do it as x dx by y dy, and then so I have brought this down, so x dx over y dy. Okay, now this is numerator and I'm bringing this down. So 3x square plus 2y square minus 8 divided by 2x square plus 3y square minus 7. Okay, now what I can do, see, various questions have various techniques to solve. Here is one new thing which you have to do: componendo and dividendo. If we apply, do you know what is it? So let's say I have a fraction a by b. If I want to apply componendo dividendo, that means you need to do numerator plus denominator, and so you need to do numerator plus denominator divided by numerator minus denominator on both of the sides. Okay, this is what you are supposed to do. So let's try. So what I'm doing, this is numerator plus denominator divided by numerator minus denominator for left hand side. Similarly, if I add this and this, what will I get? So 3 and 2 5x square, 3 and 2 5y square, and minus 8 minus 7 is minus 15. Then componendo and dividendo we are applying, so numerator minus denominator. So that means this minus this. So 3 minus 2, 1x square, 2 minus 3 minus y square, minus 8 plus 7 minus 1. Right? Still variables are not separated. Okay, in that case, let's do it in that form. If I can take common, okay, x dx plus y dy divided by x dx minus y dy as it is. If I can take 5 common, it will give me x square plus y square 5 times 3, right? Divided by x square minus y square minus 1. Okay, now I'm cross multiplying. So x dx plus y dy divided by x square plus y square minus 3, and here I'm taking this part onto the left, right? So x dx minus y dy, 5 is already here, divided by x square minus y square minus 1. Okay, you know why we are doing it? We want to make it in the form of, if you remember, integration. If in denominator I am given with a polynomial, and if I can make its differential part in numerator, then the answer will be log fx. Do you remember this rule? Integration of a fraction in which numerator has the differentiation of denominator, then the answer is log fx. So I'm trying to make that. So for that I need 2x and 2y numerator, correct? Differentiation of x square is 2x. Differentiation of y square is 2y dy with respect to x. So let's multiply with 2 here, here. So I need to do it here as well. Correct? So what have we got? Can you see? This is 2x. This is 2y dy. This is 2x. This is 2y dy. So fx is in denominator and f dash x is in numerator. Now I can integrate. So on integrating both sides, the answer will be log of denominator. So log of x square plus y square minus 3 equals 5 is already here. Log of x square minus y square minus 1, and when all of the components are in log form, so we have to take the integrating constant also as log c for general solution, right? Okay, so now what can I do to simplify it further? This is fine. You know that if any number is in, you can take this coefficient in the power form when it is log, because a log m can also be written as log m raised to power a, right? So let's apply that. X square minus y square minus 1 raised to power 5 plus log c. Now another property of log. Log a plus log b is what? Log ab. So in addition they get multiplied. So you can firstly multiply and then cancel the log by taking anti-logs. Anyways, so this is log x square plus y square minus 3, and here log c into x square minus y square minus 1 raised to power 5. Now logs are cancelled and this is our answer. So sometimes when we are saying do separation when it's not possible, so you need to figure out what can be done as alternatives. Yeah, so this is the general solution for this equation. I'm hoping that you got how to separate variables and solve the differential equation. If so, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye bye.